Bikers were one half finished with their ride at the 6 mile mark. How long was their ride? Now I know not everyone really needed a proportion on these, but we are going to set one up. So we've got the length of the race, and then the number of miles that they have already covered on these. Well, so far we know that they've done half the race, and that was 6 miles. So we want an equivalent fraction, but we want the full race. That would be one race. And we got to figure out how many miles this thing is, right? So the question is, and some of you guys would just use scale factors on this, right? So you could multiply the 1/2 by 2 and the 6 by 2, right? We usually, well, so far we've been doing a lot of fish method stuff on this, right? So for example, you could say, well, this is my unknown. So to make the fish, I get this stuff. So that'd be 1 times 6 divided by 1/2. Well, then we see we're dividing by 1/2 right there, right? And most people hate that, even though we can use calculators. But the answer should still be the same no matter which way you did it. All right, so we'll keep it like that then. But now we can figure this out. If I put that in my calculator, 1 times 6 divided by 1/2. If you do put that in the calculator, you may need to use parentheses. Yes, thank you very much. It is 12. So since it is 12 miles, the answer is not H, it's I. All right, well, we'll do number 3 then. Use the unit rate to answer the question. As it turns out, A is the unit rate, because that's really pages per 1 minute right there, singular. So if she can read 60 pages in 12 minutes, then how many pages can she read in 1 minute would be the real question. So the two things we're comparing on at these is pages and minutes. So when I set up my proportion like at these, I can label in the fraction pages and minutes and pages and minutes. All right, well, it starts with 60 page in 12 minutes. And then it tells us it's how many pages. We don't know the pages, but it's for 1 minute. So this is to set up the proportion stuff. Now, which method do you guys want to use? Fish method? Okay. So for fish method, right, we got our 4 values. We'll put them right here. 1, 2, 3, 4. Kind of add space there. So it's multiply, divide, and then equals. And I start with the x, I go down to the 1, come up to the 60, down to the 12, and then that would equals the x. So 1 times 60 is 60, divided by 12, bam, you guys got it. But the answer, as it turns out, is not 5.
Well, it's 5 pages.
5 pages, very good.
Over 1 minute.
So we should replace the x with 5 page. There we go.
Yeah, 5 pages
So,
over 1 minute.
how many pages can she read in 1 minute? 5 pages. All right, now that we have this unit rate, it should be pretty easy to figure out how many pages that Lisa can read in 10 minutes. Of course, we can set up a proportion the same way. So we can have pages and minutes. And this should equal the same number of pages per minute as a fraction. You guys want to use the unit rate or the 60 and the 12? Because it doesn't matter.
Unit rate.
All right. Yeah, I would recommend using the unit rate. 5 pages in 1 minute. And this is for 10 minutes here, right? There you go. So, yeah, even though some of you guys would use fish method on this, we can just multiply the 1 by 10 to get the 10 minutes. So 5 times 10 would be 50 pages.
You can read a lot of pages in 10 minutes.
All right, so this is 3C. John shot 200 baskets in 25 minutes. How long will it take John to make 40 baskets? Now, we used to have to write this unit rate in 2 ways, right? It doesn't say that anymore, right? All right, so we don't need to worry about this garbage up here at the top. Which means we don't really got to worry about these 2 either. We just need to solve this thing. And to do it, we'll need to set up a proportion on it, these. And we got 2 things that we're looking at. We got 200 baskets, and then we got the minutes right account. So we got baskets and minutes, and then we got baskets and minutes. So, specifically, they start with 200 baskets in 25 minutes. And then we got to figure out how long it would take John to make 40 baskets. And we could use the unit rate stuff on this, but we can also use fish method, which we love. So, to solve these, we need 1, 2, 3, 4 values. Multiply, divide, and equals. And then we got to make our fish. So we got a 40 first. That's the tail. And we got the 25 to make the head. We'll come up back up to the 200. And then we finish off at X. So 40 times 25 divided by 200. So to make 40 baskets, putting that into the calculator is what you guys did, I hope.
Yeah, 5 minutes.
So yeah, that would be 5 minutes to make 40 baskets. Jiffy peanut butter is $3.49 for a 32-ounce bottle. Or Skippy is $2.99 for a 25-ounce bottle, which is the better buy. So are we looking for a higher price or a lower price for 1 ounce?
Lower price.
Probably a lower one, right? We want to pay less dollars for every 1 ounce. So if we do it that way, then we'll need to set both of these up. Let's start with old Jiffy. All right, Jiffy. Let's set this up. We got dollars, and we got old ounces. And it's $3.49 for a 32-ounce bottle. So how many dollars would this be for 1 ounce? Well, this one usually, the scale factors comes in pretty good, right? So we just divide both of these by 32. So we divide the 32 ounces by 32 to get the 1 ounce. And then the $3.49 by 32. Alright, so it looks like it's almost 11 cents for every 1 ounce for old Jiffy. But then we got to do Skippy as well. The only reason I used 0.109 is just in case Skippy comes kind of close to it. Because if they're equal, then we got to say, well, they're the same. But I hope it's not quite as close. But we'll see. So Skippy is $2.99 for 25 ounces. But we want to know the price for 1 ounce. So, same thing on these. We should divide both these by 25, right? 25 divided by 25 is 1. So, $2.99 divided by 25 is... Alright. Well, if this is the case, we can see that Skippy is almost 12 cents. Jiffy is almost 11 cents. So, which is the better buy? Assuming they are the same quality, then Jiffy. Bam. Now this is pretty close price. I mean, the prices are pretty close. So maybe you just prefer Skippy more than Jiffy. Who knows? But in terms of the better buy, this is the answer. In 1.8 minutes, Jerry, he's going to run 1,500 meters in 5 minutes. And we got to figure out who run faster. Alright, so if Jeff, let's start with Jeff because we're comparing these two, just like the Skippy and the Jiffiness. So how do you guys want to do this? You guys want to compare to 1 meter or 1 minutes?
1 meter. Both. Minutes.
Okay, minutes. Minutes would be a lot easier on this one, right? Because whoever runs more meters in 1 minute, we can see is going faster, okay? So let's start with old Jeff. And Jeff up in here, he's going to run 450 meters, a much shorter distance than Jerry, but whatever, 1.8 minutes. And we want to know how far Jeff will run in 1 minute. So on this one, you guys want to, which method do you guys want to use?
Let's do the butter dish method.
Bam, nailed it. So we'll put an X right here. And we can see that we got 1, so 1 times 450. Let's swing this back down and divide it by 1.8. And that will equal our X. So Jeff, he's going to run 250 meters in 1 minute. But let's compare good old Jerry. And Jerry, he can run 1,500 meters in 5 minutes. So how many meters can Jerry run in 1 minute? So we can use a different method on this as well. So we'll divide the 5 minutes by 5 so that we get the 1 minute. And then 1,500 divided by 5, I get 300. So 300 meters per 1 minute for Jerry shows that Jerry is going the faster. Because every 1 minute we can see Jerry is actually, well, how far ahead is Jerry after the 1 minute? 50 meters, which is actually a pretty good distance right there. All right, what is the constant rate of change for the table below? Notice this is in multiple choice. So when it asks for the constant rate of change, it's really just asking for the unit rate, specifically in miles per hour. So how many miles for every 1 hour on a these? We can use any one of these, but I think this one should work pretty easy. So what we want though is for 1 hour, and we got to figure out how many miles this is. As it turns out, this is kind of already set up as a proportion like these. Okay. All right, this table shows the cost of ordering a certain number of tacos. I like tacos. What is the value of X if the cost is proportional to the number of tacos ordered? Oh, that's very nice. Well, we can't set up. Yeah, that'd be great. What the heck? We're almost finished, I think. So on this one, we know that on this that they've got 6 tacos. And for X number of dollars. So we just got to find another one of these comparisons. So which ones do you want? 2 tacos, 3 or 4? That sounds good. 2 tacos. 2 tacos for $2.60, right? Well, at this point we can use good old fish method because we love it so much. I mean, you could use cross multiplication or scale factors. So on at these, I'm going to go up to the 6, come down to the 260, swing it up to the 2, and then bring it back down to the X. The graph shows the amount of money Amy earns each hour she works. Which statement about the graph is not, and that's in italics right there so we can see it, is not true. So looking at this graph, right up in here, H, for 1 hour, that's right here. How much is that? That is about, that's right there in the middle, so that would be $7.50. So it's not H, because H is true. Is the line straight? Yes, it is straight. That is a straight line. A non-straight line would maybe look something like this. Very curvy. It is straight. Yep. What about proportional? Is it proportional? Well, let's see. Let's see. So let's check this value, right? That is at 2, and that would be 15.
If it was proportional, that would.
And then this one, the graph shows a non-proportional relationship. It does not show a non-proportional relationship.
Oh, I was right. I was right.
Sorry. So G.
Yes.
G, this one is false.
You said it's a little off.
Well, if it were a little off, it would just make H not true.
It's hard because it's 5
All right. Well, we could look at it like that. So as it turns out, we could go back and say, well, look, if it was 750, then it should be right in the middle, and then this value should be exactly on 15. And then this one should be at 2250. All that means is that this one also is not true. So you could have put both of those, H and G. But I was looking more for G on this than H. But it makes sense if you put H on there. All right, your uncle wants the ratio of flowers and vegetables planted in his garden to be 6 flowers to 11 vegetables. He has space for 255 plants. How many flowers should he plant? All right, so it says how many flowers. So we know we are comparing flowers. We got flowers on these. And we're comparing this to plants because we got to know how many flowers he should plant. So with the plants, we can see that up at the top that it's 6 flowers. And then we got 11 vegetables. So that would give us a total of 17 plants for 6 flowers. Wow. Now what we got to do is figure this out for 255 plants. But we just don't know how many flowers that is. I'm going to use fish method on this. So I got the 4 values on of these. 1, 2, 3, 4. Multiply, divide, equals. And up in here, we start with the x. We'll go down to the 255. Cross up to the 6. Come down to the 17. And that's x. And yes, the answer is not 90. Very good. It's 90 flowers. The length of 2 ribbons are in the ratio of 5 to 6. The length of the longer ribbon is 55 inch. Find the length of the shorter one. So our first ratio, we've got long. And this is compared to, well, I'm sorry, I'm going to take that back. The ratio is from short to long. Because it's 5 to 6. 5 is shorter than 6. So short to long. It really wouldn't matter which way you set it up, as long as you put them in the right place, though. So over here we have short to long as well. And the short would be 5, and the long is 6. So if the longer side is 55 inch, then how long is the shorter side? So that's our x right here. And we can set up this proportion and then use fish method to solve these. So I've got 55 times the fiber divided by 6 equals x. Is that right? 45.8?
45.83
Thank you.
repeating.
45.83 repeating
But that's not
inches.
the answer.
That's correct.
Yeah.
This would be in inches. So this one is great because we're just solving these proportions. And they're already set up for us, so we just got to figure out which strategy we like the best.
Fishy.
I'm actually going to use
Bow tie.
scale factors on this one. Because I know 25 times 3 is 75. Now, again, you could have used fish method on this, and you should have got the same answer. So this one I'm going to multiply by 3 as well to get the x. There it is. Alright, so that's with scale factors, but what about b? Well, we haven't used cross multiplication yet. So I'm going to cross multiply these. 9 times 4, 20. Should equals x times the 15. We'll do it on the next one. So 9 times 4, 20. Alright, so 9 times 4, 20. 3,780 equals 15x now. So to solve this, we'll divide both sides by 15. And x equals 252.
Yep.
That sounds great. Fish method, yes.
Method for C and
Alright, fish method. Yeah, we'll do fish method on the last two. So 1, 2, 3, 4 spots. Multiply, divide, equals. And I'll make my fish, so I go down to the 32. Notice the fish is facing differently than we usually are used to. And then divide by 8. But it still works. So the answer to this one is 4. This one's extremely difficult. extremely
kind of,
difficult.
yeah.
1, 2, 3, 4 spaces, multiply, divide, and equals.
This one is a long answer though.
Yeah, but it's good, right?
Yeah.
So x, we'll go down to the fjord, come up to this fjord, come down to the 28er,
And up to
and then finish off at x. So when I put this in my calculators,
it's 0.5714286.
I got 4 sevenths.
Oh, you could do that. How did you get this?
Yeah, so seventh values have, I think it's 6 decimal places that repeat. So this one will be hard to show the exact value, which is why I showed the fraction.
Well, this is the 6.
All right, so on this one, on the decimal for D,
No, it's not. Yeah, it's 571.
oh yeah, so their calculator gave more decimal places. On this one, see how we got 571 and we already had 571?
You don't say.
That means that everything is going to repeat after that point, so it's really 0.571428 with a line over it.
That's 6. You forgot the 6.